Hey everybody, Mr. Bells here. Just wanted to kind of give you an update. This is a video that I'm going to do kind of a test review for the Similarity unit, and hopefully this will help. Okay, so this document should be right there in the Google Classroom underneath the link for practice test doc, and I'm going to kind of go through some of these things. One of the main things that you're going to have to do is you're going to have to be able to do proportions. Whenever you have a proportion like this, we do something called cross multiplication. So we're going to do 3 times this x, which is 3x, and we're going to set that equal to, I'm going to move myself a little bit over here, trying to get some of that noise away from the computer that just kind of processes in with the microphone on this thing. So 3x is equal to 40, and then x is equal to 40 thirds. Divide by 3 to get the x by itself. You can leave your answers as fractions, or you can go ahead and type them into your calculator and change them to decimals if you want. So 40 divided by 3. Okay, so x is equal to 13.3 repeating. Make sure you keep the repeating portions of those if you have them. Over here, we're going to go do this one. Now I have 2x times 7, and that's 14x. Equals, and I cross multiply the other way and I get 12. Divide by 14 and divide by 14, and I'm going to get x equals, I can reduce that to 6/7, or again on the calculator, 6 divided by 7 is 0.857. I'd probably, excuse me, probably go a few decimal places as I do that. Okay, this one over here, I've got a little bit more stuff on both the numerators. So I'm still going to do cross multiplication. When I do that, I'm going to do 4 times x, which is 4x, and then 4 times 2. So I have to do it to the entire thing up there. So that's 4x plus 8 equals, when I cross multiply here, 5 times x is 5x, and 5 times negative 7 is negative 35. I'm going to go ahead and move my smaller x to my bigger x's side through subtraction. And I get 8 equals x minus 35. And I add the 35, and I get x equals 43. Final answer there. I go ahead and do this one here, and this one's kind of a, I don't know, good or bad one. But if I do x plus 8 times x plus 8, that technically is x plus 8 quantity squared, because that's what multiplying by itself means, is you're squaring it, equals 100. And instead of doing FOIL like you would in an algebra class, x times x is x squared, and 8x and 8x, and then plus 64, I'm going to leave it like that, and I'm going to be able to do a little square root symbol. Then I can get x plus 8 equals plus or minus 10. I subtract 8, and I get x is equal to, well, if it's positive 10 minus 8, or x is equal to negative 10 minus 8. So my two possible answers here are 2 or negative 18. Turns out in these cases both of those numbers work. Okay. How do we know polygons are similar? Polygons are similar if the angles are congruent and their sides are proportional. Now, you know, as we talked about this class, that there are several specific ones for triangles. Okay, but this one says polygons. So polygons could be a triangle, it could be a quadrilateral, it could be a pentagon, a hexagon, a heptagon, any of those different sides. But the angles are all congruent, which means it doesn't distort its shape, and the sides are proportional. So one could be bigger than the other, but the sides have to go in the same ratio. Okay, for triangles, there are 3 specific ones. There is SS, there is SAS, sorry, SSS, there's SAS, and there's AA. And these are not like in GOA for triangle congruence. These are for similarity. And the S's refer to proportional sides, whereas the angles refer to congruent angles. Okay, and we know that on this last one, that if 2 angles are congruent, then the third ones have to be from the third angle theorem. Okay, So number 6, it says, hey, what does x equal if the polygons are similar? So again, there's not enough on this shape right now to be able to say that the polygons are similar, but we're saying what would x have to be if the polygons actually were similar? Well, if they were similar, then I would be able to write one of these multiple proportions. I'm going to do left side over diagonal, 10 over 16 equals, and I'd have to do left side over diagonal, x over 24. And if I have that proportion, then I can solve this through cross multiplication the same way I did those ones that were up there. So I take my handy dandy little calculator, and I'm going to go ahead and do this way, 10 times 24. So and I'm going to do 10 times 24, enter, and then that equals 16x. So then I have to divide by 16, and I get that x is equal to 15. X is equal to 15. Now another thing that I could have done is I could have done and taken the bigger number and divided it by the smaller number. And if you see that right here, 24 divided by 16, you can see that I get a scale factor of 1.5. So there's a 1.5 to 1 scale factor, which means all I'd have to do is take, if I was trying to go smaller side to bigger side, I would multiply it by 1.5. And if I was trying to go from bigger side to smaller side, I would divide by 1.5. And that's another way that you can change from one spot to another spot. Okay, next one down here, it says, let me adjust that a little bit. So I got this shape right here, this person who's 6 foot tall and 2 foot wide. And then we have a miniature picture of them where they're 2 inches tall. And we want to know how wide they are. Well, if the shapes are similar, which means it's just a picture of them, so again, the angles aren't distorted, we're going to look at it as this. 6 over 2, being this 2 inches, is equal to 2 over y. And then we cross multiply and solve this, and I get 6y is equal to 4, and y is equal to 2/3. Now, as long as this is feet and this is feet, these are okay to be inches and inches. I don't have to do any unit conversions on that. And y is 2/3 of an inch, or less than 1 inch wide on the picture. Okay, here, what are the ratio of the triangles' angles are in a 3 to 4 to 6. What's the biggest angle? Well, if I was doing angles, and that's what that symbol means, that means I've got 3, a 4, and a 6. I'm sorry. Hadn't moved in a while. You guys know, sometimes you know, the lights go off in the classrooms because they're on monitors. So that's in a 3x to 4x to 6x ratio. And since it's angles, we know that all the angles add up to 180 degrees. So I can write 3x plus 4x plus 6x equals 180. And then I get 13x equals 180. And I take my handy dandy calculator and I go 180 divided by 13, and I get x to be 13.84. Please, please, please do not write that in the blank. 13.84 degrees is x, but this says what's the biggest angle? Well, the biggest angle is the one that's multiplied by 6, because multiplying by 6 is more than multiplying by 3 or multiplying by 4. So I'm simply going to take that angle and multiply it by 6, and my biggest angle is 83.08 degrees. 83.08 degrees. Okay? Now, if they said another one like this, and they were talking about sides of a triangle, and the sides were in a ratio of 2 to 4 to 5, and say the perimeter was 120, then you would write 2x plus 4x plus 5x is equal to 120. And you'd solve that equation, And if it was asking for the smallest side, once you found your x, whatever your x equals, you would times it by 2 if you were looking for the smallest side. If you were looking for the biggest side, you'd times it by 5. And if you were looking for the medium size, you would times it by 4. Whatever your x was once you solved that equation. Okay? So that's like the first set of stuff that you need to know for this test. Going here on this one, I'm going to go through at a pretty decent pace now. 9, 10, 11, and 12 are all problems where they're saying, are these triangles similar, and if so, why? Okay, so the first thing I'm going to do is I'm going to look at this one up here. And on this one, I see that lines are parallel over here. And if those lines are parallel, then that angle and that angle must be congruent because they're alternate interior angles. And this angle right here and this angle right here are congruent by vertical angles theorem. So then, yes, the triangles are congruent by A, and I could write that triangle ABC is similar to triangle, and if I went to A to B to C, it would be E to D to C. Okay? This one over here, there's no angles marked and no sides marked. The only thing that I can say is that on YZQ and on QXW, that they both share angle Q. So then what I would do is I would check to see if these ratios are the same. So I'm going to use 5 over 4, so bottom of this triangle over the vertical portion, and ask, question mark, is it equal to, if I do bottom of this triangle, I have to do bottom of the whole triangle, 8 over its portion, 7. And is 5/4 and 8/7 the same fraction? And the answer in this case is no, so therefore those two triangles are not similar. Okay? Because that's not equal to that. If they were in the same proportion, then we could look at that being another possibility, but they're not, so it doesn't matter. Okay, over here, I've got a 6 and a 13.4 to 9.6, so I've got a side, a side, and a side, and a side, a side, and a side. So what I'm going to check right now is, are the sides proportional? So I'm going to check comparing sides. So this left one to this bottom one, that's 6 to 3, so that's a 2 to 1 ratio. So now I'm going to check this one to its corresponding part over here. Is 6.7 exactly half of 13.4? And if you're not sure, go ahead and grab your handy calculator here. 13.4 divided by 2. And I get 6.7. And I got 6.7. I'm like, yeah, that works. So then is 9.6 exactly double 4.8? And again, if you're not sure, go ahead and use your calculator. And you do 9.6 divided by 2. And you get 4.8. So in this case, this side over this side is equal to this side over this side, which is equal to this side over this side. So yes, the triangles are similar by the SSS proportionality theorem. And then I could write that triangle TMN is similar to triangle T to M to N is to R to A to L. R to A to L. And I got to make sure again that those sides match up. On this next one right here, taking a look at that, and I'm going, is this triangle similar to this triangle? Well, I don't have two angles. Well, I have these ones, but I don't have a second set of angles, so I can't use AA. I don't have all three sides, so I can't use that. But there is a theorem called the SAS. And that one says that if you have two sides proportional to two other sides, and the angle in between them are congruent, then the two triangles are similar. So let's check. Is 4 over 8 equal to 6 over 12? 4 over 8 is a half, 6 over 12 is a half, so this is again a yes by SAS. And then triangle MNP is similar to triangle. And if I go M to N to P, I have to go H to J to K. H to J to K. Awesome. So again, that's what it said. On 9 through 12, are the triangles similar, yes or no, and why? If yes, write a similarity statement. So we did that. Sweet. That's good. So I'm going to go to this section down here. Actually, let me just move that camera a little bit like that and see how this goes here. So this one says 13, triangle ABC is similar to triangle DEF. Awesome. So it's telling me, which also means that A is congruent to D, and that B is congruent to E, and that C is congruent to F, because order matters. So I'm trying to solve for X. X is right there. So what I'm going to do is I'm going to look for two corresponding sides that actually have numbers, 3 to 10. So I'm going to do a 3 over 10. And if I did left side triangle over right side triangles, good deal, 3 to 10, I have to do corresponding part over corresponding part, so X over 13. And then if I wanted to do Y, I could do 3 to 10, left of this triangle over left of this triangle equals bottom of this triangle over bottom of this triangle, 5 over Y. And those are the two proportions that I can solve, and we can do that through cross multiplication, and you can check those on your own. Down here at the bottom, this is the one where we said if the lines are parallel, then the segments that they split have to be, again, not congruent, right? Little segment C and little segment F right here. Actually, let's call this segment BC, and this would be right here, segment EF. So right over here, we're saying, hey, fill in the blank. AD, from A to D, that's the whole long thing, over A to G, the whole long thing, is equal to what over BC? So A to D, left side, is A to G, right side, is equal to what over BC? So technically, I'd probably want to write this one up here. So we'll go ahead and do that, over EF. Now, if I had to do it the other way, I would write it as a reciprocal, but I don't want to do that. So I could do A to D over AG is equal to BC over EF. So a whole thing on the left over the whole thing on the right equals small part on the left over small part on the right. And again, I could still write it, but I don't want you to have to think about reciprocal functions with that, so we'll call that good. On the next one, A to C, which is here, over CF, which is here, left side over bottom, equals AD, left side over bottom. So in this case, that would be DG. Okay, let's go page 3. Trying to move through this, trying to get this thing under a half an hour here. It says, what would X have to be to make BE parallel to CD? So it doesn't say that these two segments are parallel, but if they are parallel, then we know that this would have to be true, that 6 over 5 would have to equal X over 4. That top over bottom of this equals top over bottom of this. And again, we're saying, what would X have to be in order for it to be true? Because we don't know that this statement is true unless the lines are parallel. So we're trying to figure out what X would be in order to make them parallel. So I cross multiply and I get 24 equals 5X. Divide by 5, divide by 5, and X equals 4.8. Oops, sorry. Just double check the camera. My apologies for any of that stuff. So again, top over bottom equals top over bottom, and we have to make X have that proportion be true in order to make the segments have to be parallel. Okay, number 16, have one of these ones here. So if, and this is a statement that they had in the book on it, if these two angles are split, and this is called an angle bisector, this is an angle bisector, then it splits the triangle proportionally as well. And what it does is says that 26 over X plus 12 has to be equal to 20 over x plus 8. That this over this portion of the split has to equal this over this portion of the split. Again, if, that's an angle bisector. Okay? Cross multiply here, and I get 26x plus. Now, I've got to use my calculator because the numbers are getting kind of big, and I don't want to mess it up. So 26 times 8 is 208. Equals, and then I cross multiply here, and I get 20x, and then 20 times 12 is 240, but I'll show you that on the calculator too. 20 times 12 is 240 plus 240. 6x equals 32. X equals 6 goes into 35 times, and then I have 2/3 left over. So x is equal to 5.3 repeating. Okay. Again, you can check that on your calculators. Number 17 says that this triangle ABC is similar to triangle DEF. So it might be that I want to draw the pictures right now because it might help my process. So ABC is similar to DEF. And I kind of read a little bit ahead. It said that AB is equal to 10 and that DE is equal to 16. So that's why I made this triangle bigger because the corresponding side is bigger. Awesome. So it says the perimeter of triangle ABC is 60. What's the perimeter of triangle DEF? So evidently my picture is not drawn beautifully to scale, but I don't need it to be. If I know the perimeter is 60 on this one, then I know that this one's perimeter, because they're in the same scale change, 10 to 16. If I do 16 divided by 10, it's 1.6 times bigger. So if I know the little one's 60, I simply have to multiply 60 by 1.6, and I know that the perimeter of the big triangle is 96 centimeters. Now area doesn't work the same way, and I think we've shown this before, that if I have the area of triangle ABC, that's the little one, is 50. If it was just a one distance size change, I'd multiply by 1.6, but it's area, so area affects the length and the width. So I got to multiply by 1.6 twice in order to get the new area. So I go here and I go 50 times 1.6 times 1.6, or you could use 1.6 squared if you like that, and you get 128. So the area of this one is 128 square centimeters. The stuff right here at the bottom, this goes back to the first couple things that we did in the class. List the angles from biggest to smallest. Well, the biggest angle has to be across from the biggest side. So I'm going to go angle A. The next biggest angle has to be across from the next biggest side, which would be 6. So then it's angle B. And the next biggest angle has to be across from the next biggest side, or the smallest side across from the smallest angle. And that's angle C. Now here on this one it says list the angles from big to small. Well, I can't do that unless I know what my angles are. And this one's 74 and this is 53. So there's a relationship that says 74 plus 53 plus, we'll call it MA for missing angle, equals 180 degrees. So I'm going to do on my handy dandy calculator over here, 180 minus 74, enter, minus 53, enter. And you can see that my other angle is 53 degrees. So this one's also 53 degrees. So I'm listing angles from big to small. I would have angle E followed by, and that since they're the same, both angle F and angle D. Since they're both 53, it wouldn't matter. Now, it might not be that on the test that it's also 53. It could be something else. You just have to look at what your two angles are. Okay, this one says in triangle ABC, AB is equal to 12 and BC is equal to 17. Find AC or show all possibilities for it. Well, we know that the two smallest sides, when added together, can't be bigger than the biggest side, so that I know that I have an end goal of 29. I can't have it be bigger than 29 or those two sides won't reach, and that's by adding those two numbers. If I subtract those two numbers, I know that the other side can't be smaller than 5 or they won't reach. So we write 5 is less than AC, which is less than 29. 5 is less than AC is less than 29. This next one down here at the bottom, it says, is this possible for a triangle of 4, 6, and a 10? And you would say not possible, because 4 plus 6 is not greater than 10. If that was actually length 4 and that was actually length 6, they would line straight up on top and touch right here without them ever meeting. And there's no opening, there's no triangle, it's just a segment. Okay, so I go here. I say know these vocabulary terms. Okay, so I'm just going to kind of give you some verbiage here. Perimeter, distance all the way around a shape. Area, area is the space inside a shape. Parallel means that two lines never intersect, showed by little arrowheads on those segments, or we'll parallel things like this. It says like AB is parallel to CD. Similar means that all the angles are congruent and all the sides are proportional. A ratio is something like this, 3 to 4. It's a comparison or a fraction between two things. Scale factor, it's how we change from one size to another. And the scale factor can be from small to big or big to small. It just depends on how you want to phrase it. A proportion is when we have a fraction set equal to another fraction. Usually we solve these with similar polygons that have proportional sides. Cross multiplication is the process we use to solve a proportion. And a triangle, of course, is a three-sided shape that has all angles adding up to 180 degrees. And we know that the sides, that the two smaller sides must, when added together, be longer than the longest side. Then we go to here, 23. We have this at the very beginning of the class. It says, I've given 3 points A, B, and C. They are all non-collinear, which means it will form a triangle ABC. And I've asked you to be able to find the perimeter. We did this on one of our quizzes. So I can do this, if it helps for you, because I need to find the distance from A to B, the distance from A to C, and the distance from B to C, and then add all three of those distances up. So I might go here, 1, 2, 3, 4, 1, 2. Negative 6, 1, 2, 3, 4, 5, 6, and 3, that's up here. So 4, 2 is here. Negative 6, comma 3 is here. And C is 2, comma 8, that's way up there. 3, 4, 5, 6, 7, 8. 2, comma 8 is way up there. Well, we said you could use that big old distance formula thing, right? D equals the square root of y2 minus y1 squared plus x2 minus x1 squared. You could do that. I don't know if I necessarily like it like that. So we said, I'd like for you to think about this distance in a way of the Pythagorean theorem. So how far is this? I look at the difference in the x's. I look at the difference in the x's. 4 to 2 is 2 squared. I look at the difference in the y's. And 8 to 2 is 6 squared. And I'm going to add those together. 2 squared is 4. 6 squared is 36. That's 40. And the distance is the square root of that number. The square root of that number. So now I'm going to go here. So that distance is the square root of 40. This distance, the difference in the x's, negative 6 to 4 is 10 squared. The difference in the y's, 3 to 2 is 1 squared. So that's going to get me the square root of 101. 10 squared is 100, 1 squared is 1. Then we do the last one right here. Negative 6 to 2 is 8 squared. 3 to 8 is 5 squared. And 64 and 25 is 89, and that's the square root of 89. So then on my calculator, I'm going to go, okay, what are my three distances? I got the square root of 40, plus I got the square root of 101, plus I got the square root of 89. And I make sure that none of those radicals over the top of the other problems too, just individually each number. And I hit enter, and I see that I get a perimeter for this one of 25.81 if I round it up, and I can do that. And then which one's the biggest side? Well, the biggest side is obviously the one with the biggest mark right here, square root of 101. So the 4.2, that was A, and the negative 6.3, that was B. So which angle is the biggest? The angle that's the biggest has to be a one that's across from the biggest side, and since BA is the biggest side, then I must put angle C is the biggest angle. Over here, this one looks a little bit complicated, and you know, we have maybe some challenging type ones towards the end. Since these things are parallel, then I have proportionality here for two triangles. So I can write 2x plus 3 over 16 equals, and that's left side over bottom, so I must do left side over bottom, which is 2x plus 3 plus x plus 1 over 24. 2x plus 3 over 16 equals 3x plus 4 over 24. Cross multiply and solve. 48x, move that up a little bit so you can see it, plus 72 equals 3 times 16 is 40. Oh my gosh, I can't believe I did this. 48x plus 64. And it turns out that I have two 48x's. That's a bummer for everyone. So that's what happens when sometimes you just make up these problems. So we're going to do a little tweak on this. We're going to make this a 3x. So if I've already done this in class, that's okay. We can do that. So we're going to make that 3x plus 3. And when I do that, that makes that cross multiplication here 72x, and now when I subtract the 48x and I subtract the that's not going to work either. That's going to give me a negative x. That's stinky. Okay, one more time. I'm going to go ahead and make this x plus 8, and I'm going to start this all over again. And I promise the ones on the test will work. Should have done an answer key to this before I did the video. So then I would write x plus 8 over 16 equals 2x plus 9, just adding those two things together. 2x plus 9 over 24. And then I get 24x plus, and on calculator 8 times 24, enter, plus 192 equals, cross multiply here, 32x plus, and 16 times 9, 16 times 9, enter, 144. And then I subtract 24x, and I get 192 equals 8x plus 144. And I subtract 144, and I subtract 144. And 192 minus 144, 144, enter. And then I divide that by 8. Then I get x equals 6. Now, 6 is what x equals, but my question actually asks for AC. AC is the distance from here all the way to here. And if I know x equals 6, then this top distance is 14, and this bottom distance down here is 7, so AC is a total of 21. Hope that was beneficial to you. Again, sorry about that last one. That's what happens. I just made this thing up and hadn't checked the problems before I made the video, but I wanted to get the video out to you. Please take your time with any of these ones and make sure that you can pay attention to detail, use your calculator, double check things to see if they make sense. I'll talk to you later.